Now, the partition chromatography, it is actually a chromatography which involves the two liquid phases, provided that those liquid phases must be immiscible, that is, they should not dissolve into each other, and the solute actually gets partitioned between these two mobile phase, and thus separation occurs. So here there is a stationary phase, which is again a liquid film held on a solid support, and the solid support may be silica, alumina, it may be some sort of you can say polymer, for example, you can say you have polyethylene glycol if you want to have a very polar type of support. So here the stationary phase is a liquid and mobile phase is another liquid, and these two liquids should not be miscible, that is, it should not dissolve. And here the separation occurs between the stationary phase and the mobile phase. So the partition coefficient K can simply be defined, that is the concentration of solute in the stationary phase upon concentration of solute in the mobile phase. This is the same expression which we actually used while we started our course, our journey of chromatography, while discussing the elution chromatography. So the partition coefficient, sometime it is also called as, it may be also be defined as in terms of distribution constant, that is Kc, that is the stationary phase upon mobile phase, because your solute actually your solute gets partitioned between the stationary phase and the mobile phase. It is the stationary phase and it is the mobile phase. So you define K as Cs upon Cm. You can also define in terms of number of moles of solute of stationary phase in the stationary phase upon the volume of solute in the stationary phase upon number of solute in the mobile phase upon volume of mobile phase. You can also define in terms of this. So again, we can have the partition chromatography, which is very important, and this chromatography, the idea of this chromatography was again investigated by the Martin Singe. So we have different type of chromatography. We have normal phase partition chromatography, NPPC. We have the reverse phased partition chromatography, that is RPPC, and we have the bonded phase chromatography, which is very important. So let us look one by one what is the difference between these three partition chromatographies. So now the historical background before going into the details of the three chromatography. So again, the idea was given by Martin Singe, who got the Nobel Prize for this revolutionary idea for the separation science. Separation science. So now the transition, that is, we have started from liquid and then we are going towards the bonded phase column, which are extensively used in the HPLC system. So these HPLC has become a mandatory equipment in all the pharmaceutical companies, in all the biomedical application companies, because these are the most versatile separation equipment. So again, the principle of separation remains the same. That is, if that is your solute actually gets partitioned between the stationary and mobile phase, and if your solute is having a stronger interaction with the stationary phase, then it is going to stay longer. And if it is going to stay longer, then it is going to elute later. So molecules with higher solubility in a stationary phase are going to retain longer. That is, they are actually eluting later. You can say eluting later. Eluting late. Now, if the molecules have higher solubility in the mobile phase, then they elute faster. Now, if you think in terms of partition coefficient, that large K means strong interaction. Strong interaction of solute with stationary phase. With the stationary phase. Similarly, if you have a small k, it means solute is having strong interaction with mobile phase. So this is it. And this graph is telling the story. So the moment the partition coefficient is increasing, you can say that the retention time is also increasing. So greater the value of partition coefficient, greater will be the retention time, or you can say stronger will be the interaction with the stationary phase. And converse is also true. That is, if you have a lesser value of k, that means the elution is faster. That is, in that case, the interaction with the mobile phase is high. Okay. So converse things also true. Now let us quickly check the different parameters which have different effect. So partition coefficient, it gives you the ratio of solubility with respect to the stationary phase and the mobile phase. The effect is that on this basis actually your separation occurs. Okay. Similarly, selectivity alpha, it gives you the ratio of k values. For example, for a two component system, this alpha can be defined as kb upon ka. Similarly, it gives you an idea about the resolution. Similarly, retention factor, that is, it gives you stationary phase versus time in stationary phase versus the mobile phase. And again, it indicates the retention. The resolution, the last one, it gives you that how much separated the two peaks are. And always for an ineffective separation, RS must be greater than 1.5. So we have already discussed these parameters and their effect on the column efficiency also while we were discussing the elution chromatography. So bonded phase chromatography, which is very important. Here your stationary phase is chemically bonded to some solid support. And the good thing or the advantage of this BPC is that it restricts your column bleeding. The column bleeding may be defined as the elution of the stationary phase at an elevated temperature. That is, if you keep on increasing the temperature of the column, then at certain point what happens is that your stationary phase also gets unstabilized and it starts eluting along with the different components of the mixture. So the point at which this stationary phase becomes unstabilized and it starts eluting is called as the bleeding, or you can say column bleeding. That is, you can also say that loss of stationary liquid or stationary phase. For example, you have silica with SiOH groups. Now when you react it with organosilanes, you get like this. You have this type of matrix and you actually substitute it with methyl groups. Similarly, now you have a very good stable siloxane. Similarly, if you want to have some non-polar stationary phase, then you can use the C18, that is called as octadecyl. You can use octyl. Similarly, for polar you can use cyano, because you need stable reproducible stationary phase so that you can have very effective, very good separation of your components of the mixture. So the mechanism is that, for example, here when you treat SiOH group with RCl3, then you actually get a very stable type of system, because OH group was reactive. Now this siloxane is very inert, and what you actually have done, that you actually prepared a non-leachable stationary layer with the substitution reaction. So this bonded phase chromatography actually revolutionized the whole HPLC, and by using such stationary phases that are stable enough actually increases the working life of any HPLC system. and it gives you very reproducible result in terms of number of peaks and in terms of the area under each peak. That is, you get reproducible results. Now, the normal phase chromatography, we know that in normal phase chromatography, stationary phase is generally polar and mobile phase is generally non-polar. The common examples of polar stationary phase is silica, alumina. Similarly, the common examples of, you can say the common examples of non-polar mobile phase is hexane, benzene, sometimes a little chloroform, which is a little polar, but still you can take it. Again, the mechanism, the underlying thought is that polar solutes get retained via the hydrogen bonding or the dipole-dipole interactions, and it is very good, is good for separation of various lipids, stereoisomers, polar compounds. Now, the important point which you have to remember, that here your stationary phase is polar, and if you have your solute polar, then retention time will be high, because interaction will be strong. But at the same time, if your solute is non-polar, retention time will be low, or you can say elution will be fast. That is, your non-polar analyte will elute fast, while as the polar analyte will elute last, because the moment the solute interacts, and if the solute is non-polar and your stationary phase is polar, then the interaction between the polar stationary phase and the non-polar analyte will not be too much, and it will quickly go through the column, that is, elution will be quick. But at the same time, if your stationary phase, in case of HPLC, that is the normal phase chromatography, if your stationary phase is polar and your solute is also polar, then they are having a very good strong interaction, and a strong interaction means the solute is going to stay there for longer times. That is, the elution will be slow, or you can say it will be coming at the last. On a similar analogy, we have the reverse phase chromatography, where the things become entirely opposite. Here, the stationary phase is non-polar. For example, the C18 or C8. Now here, the mobile phase is polar. Sometimes even we take water, and the mechanism is the hydrophobic interaction. Here, the hydrophobic interactions dominate. Now, this is very good for the separation of pharmaceutical compounds, which are polar compounds. Similarly, peptides and proteins, which have a charge difference. So here, for environmental samples also, here actually, on the same analogy, that here you can say that this is the non-polar. So if your solute is non-polar, interaction will be high, interaction will be strong, or you can say elution will be delayed. But on the same time, if your solute is polar, then the opposite will happen, that the interaction will be low and the elution will be very fast. That is this, that if you have a polar solute, then it will be eluting, or you can say going out of the column fast. For the non-polar, it is going to stay, because it will be interacting with the non-polar stationary phase. So you can choose your type of compound which is to separate it, and on the basis of the type of compound, you have to take whether you are going to analyze it or whether you are going to separate it by using the normal phase chromatography or the reverse phase chromatography. So this is a comparative table of normal as well as the reverse phase chromatography. So here in normal phase, the stationary phase is polar and the mobile phase is opposite to it, that is non-polar. So elution pattern will be that non-polar will be coming first. The solutes which are non-polar will be coming first and the polar will be coming last. Now the greater the polarity, the later will be its elution. Similarly, it is very good for the separation of lipids and organic compounds. Stability, again, stability is not good and compatibility is limited. Now compatibility is to be determined in terms of the nature of the solute which is to be separated. Similarly, the reverse phase HPLC is called as reverse phase because everything get reversed as compared to the normal phase. Here the stationary phase is non-polar. Okay, since the stationary phase is non-polar, the mobile phase is always polar. It is very good for the separation of polar compounds, and polar compounds will elute first and non-polar compounds will elute last, because the non-polar is going to interact with non-polar very strongly, and that is why non-polar will elute last. Similarly, it is very good for the separation of drugs and biomolecules. The stability is very good, and you can also use the aqueous friendly, that is, you can also use water as your mobile phase here. Okay, so because water is also polar, so you can take H2O as mobile phase. Let us explore the column design in partition chromatography. Here again the material is to be of very good tensile strength. So stainless steel is the very good for making the column for partition chromatography. Otherwise you can use fused silica glass. The length varies from 10 to 30 centimeter, and of course the greater the length, better will the efficiency, because the greater the length, the number of theoretical plates will increase and efficiency will increase. Here the diameter ranges from somewhere from 2 to 5 millimeter, and the silica packings is used with the bonded phase. That is, here you have to use silica as the stationary phase, and on silica you have to immobilize certain liquid. That liquid actually acts as the stationary phase. So the controlled size, pore size, so that you can have good surface interaction. Now if you have a good control on temperature, then actually it increases or it improves the reproducibility of your partition chromatography. Okay, let us also see the selection criteria with regard to the employment of the stationary phase. So the first and the foremost thing, that it should be, your stationary phase should be chemically stable, that it should not react with the you can say mobile phase. It should have a good surface area and the bonding should be very strong, so that the immobilized liquid should stay there for longer times. And again you have to do certain chemical alterations so that you can always have very stable type of stationary phase. For example, we have given an example that in C18 we have to do certain caping with regard to the improvement in the symmetry. Mobile phase, we have to choose, there are certain parameters on which we choose the mobile phase. So again it should be compatible, that it should not dissolve with the stationary liquid. Otherwise you do not end up with a good separation. Okay, again you have to use high purity solvents, and high purity solvents comes in a specialized HPLC grade. Even water comes under the HPLC grade. HPLC grade means that your solvent should be free from any impurity. It should have zero impurities. It should be free from any, you can say, UV active compound. It should be stable, and it should not have any particulate or suspended matter. That is, it should be of high purity. Here you actually decreasing the polarity, that is, methanol is more polar than chloroform, which is more polar than toluene and hexane. So actually in this case you are using the polarity as a tool for better elution, for better resolution. Now the partition coefficient formula, the same one which we have already discussed, that K may be defined as the concentration of solute in the stationary phase divided by the concentration of the solute in the mobile phase. So if we have high value, then we have high retention. That means that the solute is interacting with the stationary phase. Solute is interacting with the stationary phase. Early elution means solute is interacting, just add the word strongly, interacting strongly with the mobile phase. Here the solute is interacting, again add strongly also here, so that it is more clear now. So if the hidden factor is that slight change in polarity actually changes the resolution, and every time whenever we see resolution, we always think of RS value greater than 1.5. So a high value of K means a strong interaction of the solute with the stationary phase. Low K value means a strong interaction of the solute with the mobile phase, and that is why it is in case of less value of K, elution of is fast. Okay. Now method development. So what are the different steps? First of all, we have to select the mode, which type of HPLC we want to do, that is whether we want to do the normal phase or the reverse phase or the bonded one. Then we have to choose the stationary phase on the basis of the sample which is to be separated, and we choose on the basis of the polarity. So polarity is the deciding factor, and we always have to bear in mind the same important theory, that is like dissolves like, or polar stationary phase will have a strong interaction with the polar solute, and similarly non-polar stationary phase will have a strong interaction with the non-polar solute. So we have to remember this golden principle. So we have to select the mobile phase composition, then we have to adjust our flow rate to an optimum value, that is again following the Van Demeter equation. So we have to adjust the temperature, because temperature is also important while deciding the viscosity and also the pH. Then we have to validate in terms of accuracy, in terms of precision, and in terms of the linear result. We have already covered these topics while we were discussing the elution and the GC in detail. So again we have to select the polar compound, then we have to do the reverse phase chromatography. If we have non-polar compound, then we have to do the normal phase, because you have to think in terms of the same analogy, that is your interaction of non-polar solute interaction with the non-polar stationary phase strong, polar interaction of solute with the polar stationary phase strong, and in order to have better or fast elution, you have to change it. Then you have to take a combination of the stationary phase polar, then solute non-polar. If solute is polar, then the stationary phase should be non-polar. So again solvent miscibility should be checked with regard to the partition chromatography. Stationary phase optimization, you have to compare the retention time, because good retention will give you very good efficiency and also selectivity. So you always have to look at whether your peaks are far enough and you have a baseline separation going on or not. So you can use various bonded phases, and you can do trial runs in order to ascertain that which bond phase or whether the optimization is giving you good results or not. So end capping always improves the baseline stability. So you always have to look all these factors. Now there are certain factors by which you can optimize your mobile phase. Now the gradient elution, we know that here the composition can be changed by varying the polarity of the solvent. You actually here in gradient elution, you keep on changing the polarity so that you can have a faster and better elution of different components. While in isocratic elution, you always have a single mobile phase or a fixed composition of your mobile phase. Okay. Now flow rate, we have already dwelled or discussed a lot about the flow rate. Now flow rate should be should have optimum value, and it should be towards the higher side. So low flow rate increases the retention, okay, and of course resolution is good, but high flow rate sometimes reduces separation, and the temperature, we have already discussed the effect of temperature in terms of diffusion, and it also reduces the viscosity, and of course it leads to good separable peaks or improved peaks. Now pH control. pH actually affects the ionization of analyte, so it is good. It is to be accounted while we have to separate ionizable species, and generally we take phosphate buffer for as a mobile phase, and we've already discussed it. So these are the validation parameters. So accuracy is maybe defined as the closeness, or how much close we are to the true value. Precision means that every time we get the same result, that is the repeatability is there. That is, for example, if we are getting 5 component system, then every time we get the 5 component, not the 3 or not the 6 or not the 7. Similarly, we should have a good linearity, because response is directly proportional to concentration. Sometimes the responsibility required is up to the order of 10 to the power 7. So we have to check that what type of linearity is desired for a particular separation. Robustness, that is, we can actually measure small changes, and of course we have already discussed it, that the detection limits, that is what will be the limit of detection and what will be the limit of quantification, that how much it can detect, okay, and how much it can detect in terms of giving an analyte peak, that is LOD and LOQ. So real life applications, that we can use HPLC for the purification of antibiotics, for the purification of hormones, for the purification of vitamins, pesticides analysis, drug metabolite. We can do a lot of job. And the best thing with HPLC is that you can analyze every type of compound, whether it is polymeric, whether it is some complex, whether it is some ionic compound, okay, contrary to GC, where we can only analyze the volatile compound. So here you can analyze every type of compound. In the first lecture of HPLC, what I have said, that if you can dissolve, then of course HPLC can resolve. So there are advantages of using HPLC. The first and the foremost advantages, that you always get a very high resolution, very good, and you always get reproducible results. Again, you can get a qualitative idea and the quantitative idea. You can quantitatively separate the different components, and here the range is very good. You can separate any type of compound, okay, any type of analytes, and it is compatible with HPLC. So HPLC is the versatile, or you can say the most versatile technique of separation. And even now UHPLC has also come into the market, which is more advanced than HPLC. Now of course there are certain limitations, that it is limited to immiscible liquids, because if the liquids become miscible, then they are going to react, and they are going to clog, and they lead to inefficient separation or unidentified separation. So limitation is there. Stationary phase sometimes bleeds, sometimes because of non-bonding, or sometimes because of the high temperature stationary phase bleeding take place, that is the stationary phase becomes unstable and it starts eluting with the components of the sample. Now in certain cases optimization becomes a problem, and it is also temperature sensitive. So these are the limitations of HPLC. So again, there are certain hidden facts, that is the bonded phase chromatography columns last 5 times longer, okay, they have a very good working life as compared to the simple liquid ones. Similarly, the reverse phase chromatography is the most used chromatography, greater than 70% of other methods. So BPC is there, and that is reverse phase chromatography is the most used chromatography. Similarly, a small change in organic solvent can drastically alter the resolution. We have also seen that when we were doing the gradient chromatography. So these are the facts of HPLC. So with this, we are going to have another detailed discussion on different aspects. Till then, thank you. Have a good day.